you know that a lot is going on in mechanized tunneling, or TBM tunneling also, as it is called. And thereafter, another topic will come in October on tunnel shaft and cross passage construction. Then the next topic would be underground works and contract management, which is a very, very interesting topic. Then risks of urban floods controlled by tunnels, with some examples of how it is possible, how it has been done, what are the global experience on these topics. And finally, in February of 2022, a topic called Megatunnel Projects Linking Lands means that we have, for instance, tunnels between Sweden and Denmark, tunnels between Denmark and Germany. We have undersea tunnels. We have tunnels in Indonesia, which are called the Nusantara tunnels. There are ideas to make a tunnel between United States and Alaska, between Alaska in the United States and Siberia under the Bering Strait. So the last topic will be on these type of mega projects which are linking lands and islands. Can we go to the next subject, please, to the next slide? The next slide will be the slide which gives an outline of the 2 days presentation, starting with a foreword and then with a synopsis, then talking about rural and urban tunnels, talking about sustainability and resilience in the context of underground structures, comparing above and below ground on some samples from the Boston Central Artery project, which was a project also published and well known under the name of the Big Dig. Then we will be talking about changing technology and how changing technology is influencing projects, then hazards and events. In particular, nowadays we have basic, almost everything influenced by climate change on the one side, and on the other side by the increasing global population. So there are some hazards resulting from these aspects. Then I will talk about the Massachusetts Outfall Tunnel under the Massachusetts Bay, talking about transportation facilities, underground engineering, then the important topic of water preservation and water distribution, and I will conclude with some final words. Can we go to slide number 4, please? So what is sustainable urban space development? What does it include? It includes the selective use of materials and resources and consideration of cost effectiveness, of functionality, of safety, aesthetics, and longevity. Urbanization is squeezing surface space, which is common sense and understanding. I will talk about the development of urban space in different parts of the world, including India, about socioeconomic developments which depends on the growth of infrastructure. If there is infrastructure not growing as we have it right now in, for instance, in the United States, there is a big effort to be undertaken to renew infrastructure. China is particularly mighty because it has invested in infrastructure during the last 2 or 3 decades, and growing infrastructure, growing in economy goes hand in hand. The underground infrastructure is a challenging development of sustainability and resilience of cities. Metropolitan areas across the globe are dealing with issues such as commuting disconnects, which means traffic jam, it's just another term, and overburdened surface infrastructure. So overburdened surface infrastructure is also shown in traffic jams. Infrastructure relates to social equity, strategic community engagement, and empowerment. So infrastructure really is the key for the future development of our world, of our countries. Next slide, please. The next slide shows a synopsis, and I hope you can see the graph which shows the development of people living in urban and living in rural areas. And you can see that around 2010, we have the crossing of these two lines where the urban population development increases the rural development, where today are more than 4 billion people living in urban areas on a global scale. The United Nations did estimate in 2007 that this was the first time that more people have been living in urban areas than in rural areas on a global scale. And that means that just 1 in 3 people in urban areas are globally living in slum households. The history of population lived in very low density rural settings. Urbanization trend matches in past centuries. That means that in past centuries, when we had global population between 1 and 2 billion people, it was not a problem at all because there was enough space at that time. In history, basically populations lived in very low density rural settings. And by 2050, it is projected that more than 2/3 of the world population will live in urban areas. That means from 3 people, 2 will be in urban areas and 1 will be in rural areas. It is projected that close to 7 billion people will live in urban areas by 2050. People migrate from rural to urban areas when they are becoming richer, because in urban areas it is promising that the living standard is higher. The living standard tends to be higher in urban areas. Next slide, please. Slide number 6, which shows another graph of the city population, in particular of New Delhi. It is shown between 1950 and 2015, and you can see the increase, the constant increase of the population in New Delhi. On the lower part of the graph, you see that the urban and rural population is projected in 2020 in India, where sustainability is defined as the ability to meet present societal needs without compromising the ability of future generations to do the same. The societal needs are maintaining or improving the quality of life and maintaining long-term ecological balance. Unhealthful natural environment can negatively impact food, can negatively impact water and air supplies and degrade the quality of life and health to an unacceptable level. Resilience is an important aspect of sustainability, which is defined as the ability to respond to environmental changes, especially natural or human-caused adverse events with minimum impact on functioning. So can we go to the next slide, please? After this urban and rural comparison, we talk about sustainability and resilience. If we take, for instance, Singapore, the master plan includes extensive underground use. I've been visiting Singapore frequently over the last 20-25 years, and I can confirm that Singapore, as a limited island nation with nowadays some 700 square kilometers of area, almost 1/3 of that is reclaimed area from the surrounding sea. So well-planned underground infrastructure can positively influence land use and development decisions and can reduce vehicle use and associated impacts. It's very difficult in Singapore, very costly also, to have your own car, where this is quite different because there's much more land available in India, in different states of India. So high-density urban centers may depend on centralized services, but can capitalize on centralization to increase sustainability. Now we are coming to underground transportation infrastructure, which is, for instance, urban roads and highways, public transit subways, grade-separated and underground freight railroads, high-speed rail, pedestrian rights of way, and so on, which can address multiple growth-related challenges in urban areas. For instance, congestion, urban sprawl, if infrastructure elements are optimally designed and located. So, well-planned and operated underground infrastructure can, in many cases, improve the quality of life and sustainability more so than similar purpose surface infrastructure. So the art of the deal is to balance the use of underground and surface structure in an urban environment. Next slide, please. So this slide talks about urban coordination. The development of underground space as part of a sustainable urbanization requires coordinated communication with all stakeholders to better incorporate site-specific conditions, provide greater flexibility and long-term community needs into infrastructure system design and optimal life cycle management. In the previous lecture, we have been talking about life cycle assessment and how important it is to make long-term life cycle cost analysis. So this is reflected also in urban coordination. There is relatively little strategic coordination of underground infrastructure development right now in our city planner plans. The administrative support and management of underground infrastructure as part of an integrated, multidimensional above and below ground system of urban system is vital to the development of urban sustainability. I like to give you an example from Bangkok, where I'm living right now, which is to save Bangkok and to stop Bangkok sinking. Major infrastructure investment based on long-term life cycle assessments have to be implemented to provide future sustainable urban living conditions. Sea level rise associated with climate change poses significant risk to underground infrastructure. Therefore, all of the mass rapid transit projects in Bangkok have elevated entrances. You know, you have to climb a few steps up before you enter into the elevator or into the stairs which go down to the underground station. So Bangkok sinking is a major problem because it is a coastal city, and it shares this problem with most or almost all of the coastal cities globally. So this is a problem which has to do with melting ice on both of the North and South Pole area. Greenland is melting also. So we are facing huge challenges in the future of coastal cities, which needs urban coordination. Next slide, please. Now I'm going to compare above and below ground and have to deliberate the complexity of urban infrastructure systems. So there are several systems which are overlaying each other's and uncertainties which are associated with system design and performance increase with greater and more varied demands on both above and below ground infrastructures. It's a challenge for engineers and urban planners in order to better improve whole life cycle facility performance and overall urban sustainability with documented and validated risk-informed approaches to project planning and design, which finally comes to a balance of life cycle needs in terms of service delivery, initial cost, resilience against extreme events, and effective maintenance and operations. Next slide, please. On this slide, I'm going to compare the value and the cost. What is the value in comparison with the cost? There is anecdotal and partial evidence of the positive environmental and financial impact of replacing above-ground transportation structures with underground alignments on neighborhoods worldwide. So this is a big credo for underground transportation. There is, beyond that, according to an in-depth review of the City of Boston tax assessing records by the Globe, in the 15 years since the Central Artery Tunnel project began. The Central Artery Tunnel project is the so-called Big Dig. And the value of commercial properties along the mile-long strip that this year will become the Rose Kennedy Greenway increased to 2.3 billion, which means an increase of up to 79% of the value of the commercial properties. That is significantly, you know, all of the above ground infrastructure has significant impact on the value also. If you go underground, the above ground structure increase in value as shown in the city of Boston. That's almost an increase to double the citywide 41% increase in assessed commercial property values in the same period. So, yes, there is an increase also of city property values of 41%, but in the area where the city did go underground, the increase is almost double of that, with 71%. So when we compare the cost, when adjusted and aggregated over the entire central artery alignment, the increase in land value could be of the same order of magnitude as the cost of such difficult and expensive project. I will talk a little bit more in the next slide about that, cost and value, and how much the benefit is to go underground. Next slide, please. The next slide shows or gives an impression of challenges and opportunities with regard to underground transport. The construction of major underground transportation projects often requires significant relocation of in situ underground utilities along. Just a moment, yeah. Along public rights of way. Yes, we still are on slide number 11. The excavation work and relocation needs of the project provide key opportunities for renewing and rationalizing utility provision in an area to provide for easier future maintenance of those systems. It can provide an overall benefit to the urban community using a system of system analysis rather than a project by project analysis. So system by system means overlying systems have to be analyzed as well as project by project analyzed. Sustainability of an underground transportation system is improved when system design allow as much flexibility as possible, taking into account future use, potential for additional transportation lines, and intermodal connections. Sustainability is something provided by the underground structure. And the cost can increase initial cost, but provide for better long-term sustainability. That means that we have to look into life cycle cost analysis in order to get the real picture of the cost of the investment. Next slide. So let's talk about urban roads and highways. Underground urban roads and highways typically traverse deep below a city from portal at each end that tie into existing service road networks. That means if we take, for instance, the example of Seoul, capital of South Korea, where we have an underground system of roads and highways extending 600 kilometers north, south, and east-west. So that's a fantastic solution in order to release and to smooth the traffic jams and to reduce the traffic complexities. Tunnels can avoid building foundations and other in-place services and leave space closer to the surface for other future installations. Tunnels constructed at depths will be the lowest cost among alternative underground solutions if a life cycle cost analysis is prepared and geologic conditions are allowed and are respected. The barriers to free-flowing traffic can be bypassed, travel times shortened, and carbon emissions reduced to the same distance traveled by surface road. The diversion of traffic from streets allows more pedestrian-friendly environments in the city. However, and that will be shown on the next few slides, decisions to build an underground roadway, regardless of the benefits, are regularly contested, for example, in Seattle, in Washington State. Decision to proceed requires a vote of the people and a coming together of city, county, state, and federal representatives to reach the agreement. This process is often time-consuming and can result in increased project costs, but it is very necessary to base these investment and for this underground infrastructure on common understanding and agreements. Next slide, please. Next slide shows the Central Artery, so-called Boston Central Artery project, or the Big Dig. And what you can see here on these 4 pictures is always above and below. So you can see on the left side above picture the condition before installation of the Central Artery, and below the situation in color after the installation of the Central Artery. The same, another picture, also the same side, the same view of the city. Above, you can see the situation before the installation of the Central Artery, and below you can see what happened with that heavy traffic jammed area after the installation of the Central Artery. You have shopping areas, you have parks, you have very nicely arranged and quiet and noise protected and emission protected area after the installation. The next slide, please. So when we talk about planning and assessment for a project like Boston Central Artery, the underground transportation tunnel project required rebuilding and relocating existing underground utilities in right-of-way. The building foundations make reuse of underground locations prohibitively is expensive, precluding underground parking, tunnels, or other use in that location. Underground construction may increase cost and reduce flexibility of options for alternative future use. So that has to be taken into account as well, because most underground facilities remain even after their useful life ends. Extra cost or difficulty of reusing the space continues nearly indefinitely. Comprehensive planning effort is necessary and needs to be recognized that underground space is a resource that should be used in the best manner possible, rather than letting initial use preclude later use. Similar conclusions have been drawn with respect to limiting space debris in orbits around Earth that may prevent the use of orbits for other purposes. So planning and assessing the conditions is of utmost importance. Can we go to the next slide, please? Now this slide shows a plan of the Big Dig, and you can see this is the center of Boston. You can see that the highway number 1 and interstate highways are crossing in the middle of the city, and you can see also the arms of the nearby sea. The dig pig, and that has to be confessed, has been completed 9 years late and at an additional cost and over budget of $8 billion. So the total cost was almost $16 billion. Additionally, the infrastructure has suffered from a myriad of problems, such as substandard concrete failures, tunnel leaks, a fatal ceiling collapse, and the deterioration of light fixtures, wall panels, and other metal hardwares. Still, there have been many benefits as a result of the project. The traffic congestion has been decreased by as much as 60%, along with significant decrease in air and noise pollution. The space previously occupied by the elevated highway has been replaced with an urban park system, increasing the quality of life. The creation of more mass transit has decreased emissions and allowed for increased expansion of the city. So the big dig shows how transportation engineering can have a massive positive effect on everyday life of people. It's a wonderful example that confesses negative aspect, but overall it has resulted in very positive results. Can go to the next slide, please. The next slide is an explanation of the reuse of the excavated material. These excavated material from the Central Artery project, uncontaminated, was used to stabilize slopes and fill and cap the landfill to convert it into recreational areas. The material was transported in more than 4,400 barge ship loads to the island beginning in 1992 and was used to cap the landfill with a 2-foot clay cap. The cap created an impervious layer that would serve to keep precipitation from mixing with waste beneath and leaching into the harbor. The excavated fill was mixed with biosolids from several waste composting facilities in the New England state. Boston is part of New England, or capital of New England state, to create topsoil that was subsequently vegetated to keep cap in place. Approximately 2,400 trees and 26,000 shrubs were planted on the fill. And in 2006, a 114-acre park opened after 15 years of cleanup activities. The park is operated by the National Park Service and houses a visitor center, several miles of hiking trails, and even a swimming beach for those who want to swim. Next slide, please. The Boston Central Artery assessment refers to the replacement. Is an anecdotal and partial evidence of the positive environment and financial impact of replacing above-ground transportation structures with underground alignment on neighborhoods worldwide. Very good example. According to an in-depth review of the City of Boston tax assessing records by the Globe, in the 15 years since Central Artery Tunnel project began, the value of the commercial properties along the mile-long strip became the Rose Kennedy Greenway and has increased in value to $2.3 billion, or up to 79%. This nearly doubled the citywide 41% increase in assessed commercial property values. And when adjusted and aggregated over the entire central artery alignment, the increase in land value could be of the same order of magnitude as the cost of such a difficult and expensive project. Next slide. Next slide shows elevated before and underground after the Boston Central Artery project and the development to become a smart city. So that is very important, that you can even make an existing within long tradition, long history of the city development, you can make it a smart city if you go underground. Next slide, please. That's another project which is on the other side of the United States. Boston is on the East Coast, Seattle is on the West Coast. So there has been made a decision to bore an urban underground bypass expressway and to remove a damaged viaduct and to restore an accessible scenic waterfront. The tunnel is a 3.2 kilometer long 4-lane bypass roadway, is located deep enough under the city to avoid the century-old Burlington Northern Santa Fe Railroad tunnel in daily use, a large interceptor sewer, and existing building foundation, everything underground. The environment for Seattle as such recovers the views of the Elliott Bay, the Puget Sound area, and the mountains after removing the viaduct. We shall see in one of the next slides how this has happened. The aerial view of the Seattle waterfront on the left, comparing again on the left side before installation of the bypass tunnel, and on the right side after the construction of the tunnel. It is the waterfront and Alaskan Way viaduct and the concept of the proposed new Alaskan Way street of the same area. The new concept increases the pedestrian access to the waterfront, improves general access to adjacent commercial enterprises. So I can tell you it's really fascinating to go now, if you have known Seattle before the Alaska Way and now afterwards, it's a huge, huge gain of life quality. We can go to the next slide, please. This slide shows what has been done with this tunnel, which is a 3.7 kilometer long solution. The alternative solution included a wider and 2-level viaduct on the same alignment. The replacement of the viaduct by a wide surface street carrying significant levels of through traffic, the relocation of highway on a bridge or tunnel over or under the Elliott Bay has been assessed. Do nothing was an alternative, but not really intended to limit the traffic growth and to create a demand for better public transit through continued, more disruptive road congestion. So the discussion was alternatives between different solutions, and all this has been publicly discussed, including, of course, all the administrative institutions. So at that time, it was the biggest tunnel with a diameter of almost 18 meters in order to house all these 2-level board lanes. Next slide, please. The next slide talks about the change of technologies. In our cities, we have aging underground infrastructures, which may be susceptible to deterioration and issues associated with changing technologies, changing climate, and societal needs. Underground space development requires a long-term commitment to technological advancement in an environment that is friendly to improved planning, to innovation and implementation, all based on proper contracting. Next slide, please. Next slide shows what it means to have the underground, or to use the underground as a resource. The underground space is a valuable but decidedly non-renewable resource. It's available but non-renewable. The underground space can enhance urban sustainability only if the underground is thoroughly understood. What does it mean to thoroughly understand the underground? It means, in order to have this understanding, that we have to do ground investigations. And we have been talking in previous seminars about the necessity of ground investigation to reach a thoroughly understanding of the underground. If the underground use and reuse and the protection of the natural and built environments are incorporated into long-term total urban infrastructure system planning, we can presume that this project will be a successful project benefiting to everybody. Next slide, please. We have to follow safety regulations in our underground projects. With underground infrastructure, can safely enhance the lives of millions, but few federal level safety regulations exist to guide operational safety at a time when underground system complexity is increasing. So actually, we have to look into what regulations are available and what regulations we have to enhance in the future when we go with increased underground infrastructure investments. Greater acceptance and occupancy of underground infrastructure and facilities are likely if underground space are planned with consideration of utility, with consideration of access, with wayfinding, with consideration of safety, and finally with aesthetics, which brings the architects into closer teamwork with the underground engineers. Next slide, please. Next slide talks about urbanization in principle and in general. Market forces encourage workforce capacity growth and urban and infrastructure development, but often in an ad hoc manner that may not be consistent with urban sustainability if it's too much ad hoc done. So planning and taking time for the preparation and planning of the projects is important. Development of underground space as part of a sustainable urbanization requires expanded and coordinated communication with all stakeholders to better incorporate site-specific conditions, to provide greater flexibility and long-term community needs considerations into infrastructure system design and optimal life cycle management. So life cycle assessment, life cycle analysis, life cycle management should become in the future as an important part of every project. Next slide, of urbanization project. Next slide, please. Urban setting is a development of a multidisciplinary endeavor. Sustainable urban system is possible if decisions are informed by the links between social, technical, and governing elements of society as it occurs to some extent today. Underground infrastructure projects, however, are often undertaken on a project-by-project basis with minimal consideration of long-term maintenance or societal needs. So project by project is not enough. System by system approach has to be added to the project by project approach. This approach is inconsistent with sustainability, sometimes inconsistent. Decisions are often made among decision makers with competing political, social, and economic interests and security concerns that influence if, how quickly, where, and by what methods underground development occurs. So decisions need to be done comprehensively with all stakeholders. To maximize sustainability, there are multidisciplinary efforts needed during the entire infrastructure life cycle. So that's about urban setting. Next slide, please. This slide talks about hazards and events. As mentioned before, on the example of Bangkok sinking and floods as hazards, definitively because of climate change. We have seen that right now, in particular in Germany, where unthinkable circumstances have developed. The capacity for flexibility is needed to address emerging issues, to address new technologies and societal expectations during and beyond the operational life of underground infrastructure. New hazards associated with vulnerable and deteriorating infrastructure systems, climate change again, and security concerns, for example, may affect provisions of service, environmental quality, and personal safety. Extreme events like natural disasters, terrorist acts, and so on present still other hazards and risks. Sustainability depends on planners and engineers building and pooling capacities to anticipate and accommodate human behavior and the constantly evolving urban environment. We have seen on the example of New Delhi and on the example of India how that changes over time. Accounting for human behavior in underground space can lead to the creation of an environment that allow more intuitive understanding of safety and the underground under variable circumstances. So far about hazards and events, which needs consideration in the early planning stage. Next slide, please. This slide is a reflection of my own experience with the Massachusetts Outfall tunnel again in Boston. About at the same time, a little bit before the big dig, the Boston Outfall tunnel started about 10 years before the big dig of the Central Artery started. The Outfall for Deer Island Treatment Plant is part of the Greater Boston Wastewater Management Program. The Outfall tunnel discharges treated sewage, called effluent, into the Massachusetts Bay. The Outfall tunnel begins at a deep tunnel boring method driven 9.5 miles east of Deer Island, almost 16 kilometers into the open sea. The deep water discharge was all agreed publicly and governmental agreement. The Outfall site was chosen only after considerable scientific and technical study and public participation. Now, this Boston Outfall Tunnel has been called the tunnel to clean up the dirtiest harbor in the world. The picture on the right side shows you the schematic view of this 16-kilometer long tunnel with the risers at the end of the tunnel. So the discharge of this effluent, of this treated sewage, is through a diffuser system which consists of more than 50 pipes that rise out of the sea floor over the last 6,600 feet of the tunnel length. Each pipe connects to a diffuser cap, which splits the flow into several streams, each issuing from a small pot. More than 400 diffuser pots disperse the effluent into the 100-foot deep waters in the Boston, Massachusetts Bay, where it dilutes in a large volume of seawater. So you can see a little bit of the rise of the tunnel. And this shows also what happens if you have a treatment plant, if you have an outfall into a 16-kilometer long tunnel, and then into the open sea. It is not only the cleanup of the dirtiest harbor of the world at that time, it is also the location where the best crabs and lobsters are growing at the end of the risers, and the people are taking advantage of that also. So lobsters are a specialty food in Boston, which you should enjoy once you have an opportunity to go there. Now, just to explain you also the engagement which I have had at the time, I was the designer of the precast concrete segments of these 16-kilometer long tunnels. These segments have been produced in a separated segment plant in New Hampshire, about 100 kilometers north of Boston. And when the tunnel construction was in trouble and there was a fire in the tunnel at the time also during construction. So the production of the precast concrete segments continued, and there was not a single parking place in all New Hampshire which has not been occupied with the storage of the precast concrete segments at that time. That was in the early 2000s. Next slide, please. This slide shows how these diffuser caps looks like. It's used for the initial dilution of effluent from the diffusers. It is 1 part of 100 parts in the seawater. The Deer Island effluent quality has been vastly improved as a result of source reduction and secondary treatment. With secondary treatment, 85% of the suspended solids, 85% of the oxygen-consuming material, and up to 90% of the toxic contaminants are removed from the treated wastewater before it is discharged into the open sea. The disease-causing microorganisms are better reduced by secondary treatment because disinfection is more effective with less solids in the wastewater. So that is really a fantastic project, which is a wonderful example of underground infrastructure engineering. Next slide, please. The next slide is talking about transportation facilities. The long-term sustainability of urban areas is positively affected by the availability of underground transportation systems. So cities such as Singapore, as has been mentioned before, have benefited from master plans designed around underground transportation systems. Well-planned transportation systems tend to reduce the urban sprawl, the saving landscape and protecting biodiversity, and can positively impact land use and development decisions. Urban sprawling also is sometimes called the eggplant of urban development. To provide safe and efficient transportation and decrease the need for and use of automobiles, of cars, reducing congestion and travel times, which in turn reduces fossil fuel use and respective emissions. So transportation facilities putting underground in urban environment is really, really benefiting to the society. Next slide, please. There are challenges and opportunities for transportation systems which will benefit strongly from technical advances. In design and construction, new lining and underground construction technologies are needed that reduce material use and improve long-term facility performance. Underground transportation systems usually represent key infrastructure elements pivotal of urban mobility, sustaining economy, providing also quality of life. Underground transportation system may not be designed, operated, and maintained for their maximum contribution to overall urban sustainability. Underground transportation construction projects require significant relocation of in situ underground utilities. Major excavation work and relocation needs of the project provide key opportunities for renewing and rationalizing utility provision. While this presents an extra burden on transportation project, it can provide an overall benefit to the urban community. Transportation underground system and long-term sustainability is improved when system design allow as much flexibility as possible. So that is always taking into consideration system design, technology change, and flexibility. Next slide, please. This slide talks about underground urban roads and highways. Overloaded and congested urban surface arterial roads like the Boston Central Artery can be relocated to aerial or underground alignment to obtain grade separation between above ground and below ground. Tunnels relieve surface of crowded traffic, relieve noise, relieve pollution and congestion. Multiple transportation levels provided by tunnels may allow dysfunctional arterial roads to be replaced with functional surface roads. Removing traffic to a tunnel may also result in brighter and quieter environment, improve the neighborhood, and increase property values. Underground urban roads and highways typically traverse deep below a city from portals at each end that tie into existing service road networks on both ends. Tunnels avoid building foundations, it goes underground foundations and other in-place services and leave space closer to the surface for other future installations. Tunnels constructed at depths will be lowest cost among alternative underground solutions if a life cycle cost analysis is recommended and prepared. Barriers to free-flowing traffic can be bypassed, travel times can be shortened, and carbon emissions can be reduced for the same distance traveled by surface road. Decisions to build underground roadways, regardless of the benefits, are regularly contested and have to be and are challenged and have to be fighted through by underground engineers. Next slide, please. Contributions to sustainability and resilience through underground engineering. Now, urban setting is a system of systems, and the broadest, why it's a system of systems, because we have underground communication facilities, we have sewage facilities, we have mass transportation facilities, highways and roads. So the broadest relationships between underground space use and the essential elements are implemented for urban sustainability. The physical qualities of infrastructure related to transportation, related to shelter, to food storage, to water transportation, and key material resources that contribute to sustainability or make them vulnerable to hazards shall be described. The risk is focused on more direct relationship in terms of maintaining enduring livable communities and enhancing risk mitigation through the use of appropriately planned and designed underground facilities. Advances in human safety issues, analytical techniques for life cycle cost assessment of underground facilities, and the broader triple bottom line analysis. The triple bottom line is the bottom line of financial, economic, and social performance, and the specific technological advances associated with enhanced sustainability shall be discussed in the context of safety. Next slide, please. The commercial, urban, and industrial facilities in a sustainable urban area must provide necessary commercial, industrial, and institutional infrastructures that support and manage a viable economy that provides jobs and deliver support. The relationship between urban density and land prices tends to create a market for large, multi-story commercial and institutional buildings in the high-density cores of urban areas. A future slide will explain that in a better understanding what we understand under urban density. It can be desirable to place various types of commercial, industrial, and institutional facilities underground. However, this is not the only use of the underground that is important in the urban core area. The increased size and density of buildings in the urban core areas require an increase in the capacity of urban utility and the transportation services, both in the core area and in the outlining area. Underground offers protection keeps them near populations they serve, and allows provision of critical lifeline services and emergency response while preserving above ground real estate for other needs and uses. Next slide, please. The next slide talks about the preservation of water resources, another important infrastructure element. The long-term urban sustainability implies that an urban area has balanced its water supply possibilities. The weight is on balanced water supply. Where groundwater is important water resource, a sustainable water supply would not be depleted, polluted, or diverted. Construction activities may produce runoff with sediments and pollutants that may negatively impact water quality or quantity. We are talking a lot about the pollution of water and through the microorganisms in our global oceans. Agricultural practice may have long-term impacts on water quality and the regional environment. Increased salinity of surface water and groundwater caused by evaporation and dissolution, and attendant changes in habitat for flora and fauna can be the direct result of water use practices. So we have to focus on preservation. Next slide, about distribution, water distribution. A good stewardship of underground water resources can include the use of the underground for urban development, because more natural landscape can be preserved for groundwater recharge. Water distribution facilities can be placed underground, allowing land to be developed in ways that enhance quality of life in cities. The careful analysis, construction, and operation approaches are needed to avoid changes in groundwater level, flow patterns, and pollutions. Groundwater pollution can become a major issue. The pollution legacy of underground gasoline storage tanks at service stations is a well-recognized example, as are cleanups of industrial pollution sites. So again, the underground solution offers the only way to get control of these polluting situations. Now we come to the next and last slide, which shows a sort of a conclusion or a final word. The process of urbanization in India through history is its long tradition dating back as far as about 5,000 years, maybe more. The urban tradition in India continues throughout these centuries, where well-infrastructured, big and beautiful cities. The majority of developing countries, the rate of urbanization is fast, unaccompanied by industrialization, but rapid growth of infrastructure and service sector in economies. The picture shows a map of India, and you can see where we have more urban density and where we have less urban density. You look at the area of New Delhi, Kolkata, Mumbai, or Bangalore, Chennai, and so on. So all these cities shows how much urban density is increasing and has to be considered in the future. The future growth of world's population is supposed to take place in urban areas with developed underground use. Only 31% of population of India lives today in urban areas. India urban population will be close to 35, from 31 to 35 in 2020 and about 40% in 2030. So it's increasing very fast. But by 2030, another 225 million people will be added to the Indian urban areas. So that means that the chance to use the underground technology in all of the examples which I have mentioned, from the point of view of water control, of water distribution, of sewage control and sewage dissolution, from the point of view of going underground with transportation facilities. The underground offers the chance to make use and to improve the quality of life of the next few decades. So this population density card is the final presentation of today's seminar. And I would like to thank you for your attention and would like to assure you that any question is warmly welcome and will be responded either immediately or in writing, whatever is preferable. Thank you very much. If you...
Yeah, thank you. Ladies and gentlemen, anybody having any questions, you can raise that question now. Or if you want that, okay, you would like to write to Professor, even that is welcome, that he will in specific answer your query. Anyone? Okay. Well, it appears that there aren't many questions. Maybe people are thinking about it and they will write separately to Professor Wagner. So let's conclude the session now. Firstly, I think on behalf of DTAI and all of you who are present here, let me thank Professor Wagner for a very, I would say, elaborate, very extensive research that has gone into his subject matter for the day. He's covered almost all aspects of the underground space as related to the infrastructure and other facilities, including the challenges involved. He is given very specific examples as to what were the challenges and what were the outcomes. Okay. So thank you very much for sharing all this with us. Ladies and gentlemen, we must remember, he's already brought it out that the way our population growth is, our population matrix is changing. By the year 2030, 40% of our population shall be residing in the major cities. The cities, I have already said, the cities have a finite limit beyond which these cities cannot grow vertically or even horizontally. Cities will have to go down to locate certain services, especially. Delhi is an example. And you've seen that with the metro arriving on the scene, how much it has impacted our daily life. It has added to a certain degree of comfort and ease. And also, it's made a huge socio-economic effect. I'll give you a small example. You want to go to, from whichever part of the city, you want to go to CP, Connaught Place. There are ways of converging there. You want to drive in your own vehicle, it will take you 2 hours to reach there, another hour to park, another hour to get out of it. But you take a metro. Very close, not even a kilometer, half a kilometer away from there is that Chhatrapati Shivaji station there. But I am now highlighting, if you look at the station is no longer just a metro station. It is housing the visa centers. It is housing the eating places. It is housing small shopping kiosks. So the whole thing is merging as an experience. You can go there, you can spend time there, you can move around there, you can buy things there, you can have your bite there, and then take your metro ride, come back home. Safer, better, cheaper, and faster. So that's the way the whole system is evolving. And other than we're just talking of commuting, or we're just talking of the transportation, Professor Wagner has already highlighted that locating your underground facilities, especially the utilities, your drainage, your sewage, okay, your water pipelines, your electrical pipelines, and your other underground services. I think this is the future. We have to grow. The caution is we are doing this worldwide. We are doing this, and we have a tendency, especially the engineers and the urban planners, are brought on the scene very late. We have a tendency to do it piecemeal. You cannot do that. You have to think beyond. You don't think of just that one project. You have to think beyond what will be the shape of the underground space 10 years later, 30 years later. It is not like overground. You cannot demolish it and reconstruct it. Once you create something underground, it is forever. You cannot tamper with that space every now and then. So you have to be very, very careful, and a very thoughtful planning has to go into it. That's why I will try and highlighting that our urban planners have a very, very important role to play. And we are trying to associate more urban planners with our TI also, that they are they're an integral part of the tunnels and the underground space. Anyway, I think I should stop here. Once again, thank you, Professor. Like always, pleasure listening to you. Your own knowledge is impressive. The way you explain things is impressive. And you have given us a total rundown. I think we're going to continue to have the advantage of listening to you almost every month. Thank you, sir. Thank you once
again. Thank you very much for your concluding words and for your really wonderful understanding. You know, I have to confess at this time that I'm a big admirer of India and Indian culture and Indian history and Indian feelings. You know, I think it is something which is very, very unique in the world, and this is something which India can give and teach to the world, that this capacity of uniting adverse understandings, and you bring adverse understandings on the same table and you discuss it. So uniting is the big strength of India in my view, and I much admire it, and I love it. I have to admit that really it's a wonderful experience anytime I'm in contact with India. I've been so many times in Mumbai and in Delhi, and I visited in the early 70s Agra, and at that time my brother-in-law was the Austrian ambassador in Delhi at that time, so I visited my sister at that time, and we all love India really. So including the food, including those aspects, you know. So thank you very much for your warm words and concluding your remarks, General Suresh. I really appreciate it. Thank you.
Thank you once again. Thank you, ladies and gentlemen. Okay, we can leave now.
Thank you all. Thank you to our participants. Thank you to our Senior Vice President, Deputy General Suresh Sharma, and thank you to the speaker of the day, Dr. Halal Wagner, for sparing his valuable time for conducting today's virtual training session. Thank you all. Stay safe, stay healthy. Thank you. Goodbye.
Thank you very much.
Thank you, sir.
Thank you. Stay healthy, strong, and good luck.